to teach me now. Today we're coming back with another fire video. I hope you all are ready, having your pen and a paper there with you. So our today's topic is based on sequences in series, grade 12 topic. So without waste of time, let's just get down to it. But before I start with the question, I just want to explain something quickly. Let's say for an example they give you 1 plus 2 plus 5 plus 7 plus 9. And then they give you 1 is to 2 is to 5 is to 7 is to 9 as well. So now let's check something. Numbers on your left hand side here, they are separated by signs like plus or minus, right? And the numbers on your right hand side are not separated by signs like plus or minus. So with that being said, now we can conclude to say, okay, this is a series and then this is a sequence, right? So by now, I think now we know the difference between a series and a sequence. So now we can go back to our question. Our question 2.3. So this is 2.3.1. So consider the geometric series. As soon as I see the term series, I think of terms separated by a sign like plus or minus, right? So this is our first term, T1. This is our T2, and this is our T3, right? For which values of x is the series convergent? So as soon as I see the term convergent, I think of R being in between 1 and -1. So how do we find R? We need to say T2 divided by T1, right? So what is our T2? We have 2, 3x minus 1 squared divided by 2, 3x minus 1 to the power 1, right? So since we have a square there, which means we need to open two brackets. And then only one bracket. So we have 3x minus 1, 3x minus 1, as well as 3x minus 1. Cancel and cancel. Now we're left with 3x minus 1. So T2 divided by T1 is equals to 3x minus 1. That's T2 divided by T1. So now let's find T3 divided by T2. So this is our term 3, which is 2 open bracket 3x minus 1 cubed over 2 3x minus 1 squared. 2 and 2 cancelled. Now we need to open 3 brackets because of that cubed, and then 2 brackets because of that squared. So we open 2 brackets. We have 3x minus 1, 3x minus 1 again. Even here we have 3x minus 1, and then we're cancelling out now. And T3 divided by T2 is equals to 3x minus 1, which means our R is equals to 3x minus 1, right? So we got our R as 3x minus 1. So now, without waste of time, let's answer our question now. So let's go back to the statement. It says R should be between -1 as well as 1. So in place of R, now we substitute 3x minus 1, right? So now we need to have 3x minus 1 because we said R is equals to 3x minus 1. And then we transpose that -1, right? And we end up getting 3x 1 plus 1, -1 plus 1 gives us 0, 3x, and then this one gives us 2, right? And we divide by 3 on everything, and then we end up getting x in between 2/3 as well as 0. So this is our answer, right? So we've answered our 2.3.1. Now we need to answer 2.3.2. So now let's go back to our question. Calculate the sum to infinity of the series if x is equals to half, right? So now our x is equals to half. Our a is equals to 3x minus 1, right? And then our r is equals to 3x minus 1, right? So therefore our a is equals to 2, 3. When we see x, we substitute half, right? And then we also substitute half even here, right? And we get 1 as our a, and then for our r we get 1/2, right? The reason I've calculated r and a was because the formula for sum to infinity is equals to a divided by 1 minus r, and our a is 1 minus our r is 1/2, and we get our final answer is 2. So our sum to infinity is equals to 2. So now I've answered 2.3.2. Now let's go to 2.4 now. Let's go to 2.4. So this is actually 2.4. 2.4, right? So we have 2 is to x is to 12, and then is to y, right? Are the first 4 terms of a quadratic sequence. Qubit quadratic sequence. We know that this is a sequence with a second difference. So if the second difference is 6, now our second difference is 6. So how do you find a difference? For you to find a difference, we subtract the terms. So term 2 minus term 1, right? And then term 3 minus term 2. And then term 4 minus term 3, right? And then now we need to find out what? Our second difference, which is what? 6 given to us. So now we need to calculate the values of x and y. So before we even continue, we need to say, okay, we add those two. X minus 2 plus 6 should give you 12 minus x. I repeat myself. X minus 2 plus 6 should give you 12 minus x, right? So we need to say, okay, x minus 2 plus 6 should be equals to 12 minus x, right? And then we say x plus 4 equals to 12 minus x. And then we transpose x as well as transposing 4. So we have x plus x equals to 12 minus 4. 2x equals to 8. We divide by 2 both sides. Remember, now we're solving for x, so we need to isolate x. So x is 4, right? And then we continue. We apply the same thing here. So we need to say 12 minus x plus 6 should give us y minus 12. 12 minus x plus 6 should give us y minus 12. So we need to have 12 minus x plus 6 equals to y minus 12, right? And then as from here, Remember now we've already found our x is 4. So whenever we see x, we substitute the 4. Y minus 12. And then we transpose that 12, and negative 12 rather. So now we have plus 12 equals to our y. And then as from here, we use our calculator and then we get 26 as our y. So we got 26 as our y, right? So our x is 4 and our y is 26. So now we need to confirm our answers by substituting the value of x and y back to our sequence. So we had 2 is to x, but then now we substitute 4, and then is to 12, and then is to y, but then now we substitute 26, right? Now we need to subtract, right? 4 minus 2 we get 2, and then 12 minus 4 we get 8, and then 26 minus 12 we get 14, and then we subtract these, we get 6 and 6. So this is our second difference, right? Our second difference is 6. And if you can check here on our question, they gave us our second difference as 6, which means we've answered our question. The value of x and y are correct. Your tutor from Teach Me Now, signing out.